Hi, make sure that you have your periodic table handy. Remember that you can pause this lesson at any time, and I encourage you to do so for all our examples so you can work in advance and then check how you did. We're going to be learning about how to draw a Lewis dot structure and a Bohr electron dot diagram today. Valence electrons are the outermost electrons in an atom, and it's these electrons that are usually involved in our chemical changes. It's not that the other electrons aren't important. They absolutely are, and they matter tremendously in terms of overall trend. But when we're forming bonds, it's the valence electrons that get involved. And that has to do with atoms wanting to be stable. Atoms always want to try to form their most stable state. And in order to do that, the pinnacle of stability would be behaving like a noble gas. Noble gases are over in group 18, and they don't react with anything at all. They're the most stable things that we've got, and that's because they have a stable octet of electrons. That means that they have 8 electrons in their valence shell. Okay, so all other atoms are always going to try to get 8 electrons in their valence shell however they can. They might give some electrons away, they might steal some electrons from another atom, or they might share electrons with another atom or more than one atom. That's our whole principle of bonding. If you learn how to draw these Lewis dot structures accurately, it really will help you with bonding later. Now, these are sometimes called electron dot structures and sometimes called Lewis structures, and somebody decided to put both of those names together, and sometimes they're called Lewis dot structures. Don't get confused. If you hear dots, it's all the same. We start with a symbol that's going to represent the nucleus and all the non-valence electrons for our atom. That symbol would be like O for oxygen or AU for gold. You find that symbol on the periodic table for that element. And that represents the kernel. The kernel is, well, not that kernel, and no, not that kernel, this kernel. It's the nucleus and all the non-valence electrons. Then we draw dots to represent all the outer valence electrons. I think the best way to learn to do this is to just jump in and try it. So get out your periodic table and find the electron configuration for sodium. If we look on the periodic table, we find sodium in group 1, period 3. And its electron configuration is located in the bottom left-hand corner, and it is 281. So we would fill in 281 as our electron configuration. Now remember, if we want to be stable, we have to have 8 electrons in that last level. And does sodium? No. So is it stable? No, it is not. Which of these 3 shells is unfilled? That would be the third shell, would be unfilled. Now we're going to draw the Lewis dot structure for sodium. We start with our kernel, which is the symbol for the element, in this case Na, and then we fill in our electrons around it. And sodium only has 1 valence electron, so that makes it very easy. We put our 1 dot on top. We always start on top whenever we're drawing out our Lewis dot structures. Now let's try one that has more than 1 valence electron. Go to your reference table and find the electron configuration for radium. Radium is in group 2, period 7. And you'll notice that its electron configuration starts with 18. It doesn't mean that it has 18 electrons in its first shell. This says we don't have room to show the first 2 shells. So whenever you see that little dash at the start, don't forget that still means we have the first 2 electron shells being represented. So that means we are 2, 8, 18, 32, 18, 8, and 2. So what was that? 2, 8, 18, 32, 18, 8, and 2. Which shell is unfilled here? It would be the 7th shell. Now, if you happen to notice, that's the 7th shell, and radium in period 7, if you remember that the period number always tells you the number of shells, you know exactly where to look to find your valence electrons. So our 7th shell is unfilled, and that is our valence shell. Is this atom stable? Well, does it have 8? No, it doesn't. So now we write out our symbol for radium, which is Ra, and we start at the top and we fill in our first dot. Now, since we have only 2 valence electrons, we're going to put both of those dots. Ooh, that's a messy dot. Let's try that over. We're going to put both of those dots on the top. Okay? Because the first pair always goes in the air. Okay, so the first pair always go together. Now, let's move on and try one that's a little bit more complicated. I'd like for you to draw the electron dot diagram for oxygen. Please pause the screencast while you draw your dot diagram. If we look at oxygen, we find it on the periodic table. It's over here in group 16, period 2, and its electron configuration is 2, 6. So if we were to draw the electron dot diagram for oxygen, we would start with the kernel. We start with our first 2 dots, but we still need to fill in 4 more. And here's how you do that. You put 1 dot on the right-hand side, 1 dot on the bottom, 1 dot on the left. It doesn't matter if it goes in the top or the bottom of the pair as long as it's on the correct side. Now that only gives us 5. Now since we've gone around once, we start again pairing up our 6th dot with the 3rd one that we drew. If you notice, this leaves 2 empty spots for future electrons, and that's where later on we're going to form bonds with oxygen. Now, try drawing the electron dot diagram for fluorine. Pause the screencast while you do. If we look at fluorine, fluorine is in group 17, period 2, and its electron configuration is 2, 7. So when we draw out the electron dot diagram for fluorine, we fill in our kernel, which is the symbol for fluorine, and our electron configuration was 2, 7, so we need to fill in 7 electrons for our valence level. 1, 2, first pair in the air, they're paired together, 3, 4, and 5. Now we're going to start going around our circle again, 6, and 7. And you'll see here we have, once again, an empty spot that we can potentially fill later with a bond. If you can't remember how to draw the Lewis dot structures, I've provided the rules for you in your notes. But I think it's something that if you simply practice it, you'll get better and better as you go.